Hello everyone, my name is Kevin Palmer,
My name is Mohammed Al-Harim.
and today we will be presenting about Google Robotics. Alright, just as our overview, we're going to start off with the introduction, move on to the background, then current designs, then possible future developments, followed by conceptual designs, and summarize everything at the very end. Alright, to start off with the introduction, we're going to give you the definition, the Google definition of what is a robot. A robot is basically a machine capable of carrying out a complex series of actions automatically. Now, before Google was ever invented, there were ancient scientists and inventors and philosophers that came up with automatic machinery that was self-propelled, self-capable, And this ranged from artificial birds and humans to industrialized tools for development and manufacturing that we're going to go more into depth later on in the presentation. Which brings us to the next topic, which will be Google X. It's a semi-secretive company that's working on future tech, and its main goal, it strives to develop machinery at a rate of 10 times the current rate, 10 being the X as the Greek Roman number, which explains Google X, the name. And lastly, we're going to let you know what to expect. Robots deeply rooted into human society is basically our idea of the future for robotics.
So just a little background here. Many of us regard robotics as a recent innovation, only been studied for the last few decades. But in fact, it's been studied since the beginning of time. The Greek engineer Hero of Alexandria wrote two texts describing many wonder machines, is what he called them. Pretty much the robots of the past. They were powered by steam, water, air pressure. The first such design was the pigeon. This is a sketch. It was a wooden bird propelled forward by steam. It could fly up to 200 meters forward as long as it was held on by a string. Another example would be Leonardo's robot pictured here. It was designed by Leonardo da Vinci to make a suit of armor move as if there was a human inside of it. It was meant to amuse royalty, and it worked within a system of interconnected pulleys. The development of robots kept being for entertainment purposes mostly, such as these, up until the 19th century when the Industrial Revolution came about and more steam-powered and efficient machines came about, and then they were used for factories such as Henry Ford used the first conveyor belt system to design the Model T in 2.5 hours rather than 12 as it would usually take. An example of such efficient robots would be, over here we have a robotic arm device used to transport die castings from the conveyor belt into their place at a much faster rate, and since they were at a hot temperature, the robot could do this whereas a human couldn't. It's called the Unimate. It was designed by George DeVoe in the 1950s. His company, Unimation, is considered to be the first robot manufacturing company. Of course, robotics have advanced at a much faster rate nowadays. Google's robotic department is called Google X, as Kevin previously mentioned. Their lab started up in 2010. To help expedite the startup process, they bought out 8 already established robotics companies such as Boston Dynamics, DeepMind Technologies, and Mecha Robotics. But no one really knows the intent of Google in their robotics search because they don't release much information about it. But it's believed that it's mostly a financial move, as 95% of their income comes from advertising, and they believe that eventually that market will dry up and we'll need something else to fall back on. One example of this robotic endeavor that they've taken is the M1 mobile manipulator. It was inherited from Mecha Robotics. It has a Microsoft Kinect as a head to help visualize. It has an omni-wheel base, so it's very mobile, nimble, it's versatile, and it handles forces very well, although it is not very strong. It's not meant for an industrial use, it's more for a research use. It can handle things very nimbly, and we have a little video. So now we have Project Wing. It's something Google X has been working on for over 3 years now. Its primary purpose is to deliver packages. It's a drone that can move straight up and down, doesn't need a runway to take off or to land. Once it reaches its destination, the package, which has been stored within the drone, is lowered down by a string, and then it has something that they call an egg at the bottom. It's a bunch of electronics that detect the touching the ground, and once it touches, the drone will release the package and move on. As far as the more famous robots from Google X that perhaps you have heard of are the Boston Dynamics robots. They were designed to be strong, fast, and very mobile, to be able to move through unexpected terrains. One example is the Cheetah over here. It's designed to run up to 29 miles per hour. The original purpose of these robots, they were being designed for the Department of Defense. They were funded by them as well, but once Google bought out Boston Dynamics, they ended all relations with that. Here we have Atlas. It's more of a humanoid robot. It stands 6 feet 2 inches tall, 330 pounds of aluminum, steel, and titanium. It's designed to be bipedal and trek through unpredictable territory without tumbling or falling over. And the only drawback is that it has to be tethered to a power supply as of now. They just had a successful run through a forest where it did not fall over though, so now they are working on a solution to remove that power supply so it could be completely independent. There is also additional software that can be applied to Atlas to make it drive a car or carry a fire hose, so you can see how there are future applications to this if it were to be successful. Here we have a video.
Moving on to possible future developments, Google X is currently working on technology with science fiction sounding solutions. And some of the many projects that they're working on include these few ideas that we've mentioned here, which is an artificial human visual cortex, robots with downloadable personalities, mass control of robots via device/system, and cancer and heart detecting nanotech. The human visual cortex is basically a project that can help robots learn and adapt through just visual interactions with images, people. They've used images of people and cats in order for the processors to recognize an image in the future and recall it on its own without having to have a visual reference. Robots with downloadable personalities, you can see those nowadays, especially in Japan. There are robots that help people in banks and will play music for you if you're upset. Mass control of robots via device or system, you can think of the cloud or a tablet or your smartphone in order to get multiple robots to accomplish various different tasks that have nothing to do with each other. And lastly, but not least, cancer and heart detecting nanotech. It'll be in the form of pill in order to ingest, and it doesn't get detected by the antibodies as a threat in order to preemptively detect cancer and heart attack and other various diseases. But right now it's really on the down low. Google hasn't revealed too much about it, but it's definitely in the works. Lastly, conceptual designs that we've thought of. You can see it nowadays in video games, television, novels, comic books, anything you can think of, modern day entertainment. A lot of conceptions is moving towards a more realistic design of a robot. If you know the show Humans from AMC, as you can see in this picture, robots in this television series have superior vast standards of artificial intelligence, also known as AI, by today's standards, and they're sophisticated enough to be integrated into society and perform countless numbers of routines to blend in even with people around them. Alright, as for the summary, just to recap everything we told you about the introduction, the background of robotics in general, current designs, just a few of the many, as well as the possible future developments that Google X is currently working on, our own conceptual designs, and the summary.